Video is to help you use Desmos to answer probability questions with the normal curve. First, let's look at the graph of the standard normal curve. The function in Desmos is called normal dist. And you can just type it in with the mean and the standard deviation. Or you can also find it under the function menu. Scroll down to distributions. There it is, and it's right there, normal dist. So you can choose that too. So this is the normal curve. If you click on this little magnifying glass right here under it, you will get a zoom into what you should be seeing for that curve. So here the mean is 0, and the standard deviation is 1. 1, 2, 3, -1, -2, -3. And that's how much you should be seeing of the curve. If you click on CDF, which is the cumulative distribution function, you'll see a lower min and an upper max. And in this box right here, you're actually given the probability. So this is giving you the probability of 1 or 100% that if the minimum is less than down by -infinity, and if the max is positive infinity, meaning all values. So what's the probability of getting any value on the real number line? And that is 100%. So let's just do a couple of these. I can just type in -1 to 1, and look, we get 68. So this is actually one standard deviation on both sides of the mean, and as we know, that should be about 68%. If we want the values greater than, let's say, 1.45, and if I delete this other one, automatically you're given infinity. So this value here is the probability that a number is greater than 1.45, which is 0.7. If you want the other side, if you want it negative, the same thing will happen if you just leave it blank, and I say 1.45, and that should be 1 minus what we just got, right? So about 93%. You can also work with the mean and standard deviation not being 0 and 1. So suppose you know that the mean infant weight at birth is 3,626 grams. Let's put that in. And let's assume that the standard deviation is 541 grams. Oops, don't need that. So right now, I'm going to press the zoom, again, zoom fit. And now all of a sudden we see that the mean of this normal curve, I should say, is at 3626, right? And the standard deviation is 541, so about 500 times 3, which is about 1,500 or more, should be like right there, and the same thing on this side. So, and I could move it to look at it at the same thing. So this is a normal curve, it's just not the standard normal curve. So what if there was a question that says something like, what's the probability of a baby weighing more than 3,800 grams? So if we did 3,800, and this we just delete, and it becomes infinity, and this says 37%. So it's a 37% probability that the number, the weight of the baby would be greater than 3,800. And that's the same if you want to do it in between two numbers. Let's say, like, what is it between 3,600 and 3,800? That is about 14% of all babies weigh between 3,600 grams and 3,800 grams. Let's do one where it's less than. So what would what's the probability that a baby is pretty small, like weighs less than 3,000 grams? And that's about 12% of babies would have a weight less than 3,000. So what if the question is like, what does a baby's weight have to be in order to be in the top 10% of all babies. So this is kind of like the inverse question, right? It's asking you not for the probability, but for the value of the baby's weight that puts them in the top 10%. So one of the things that we do is we have to define the distribution. So I'm going to say normal dist 3626 541, and then you put a point and you put in the function inverse CDF and the value. So if I want them to be in the top 10%, the value that's below that is 0.9. And in order for a baby to be in the top 10%, they have to weigh 4,319 grams. So you would use this inverse CDF if you're actually looking for the value that gives you a specific outcome. I hope this was helpful.